Today we're going to look at graphing systems of equations and also go back and look at what we did on Friday, which was solving systems of equations by the substitution method. So we start here with the Martinez twins. Carlos and Clarita are trying to find a way to make money during summer vacation. When they overhear their aunt complaining about how difficult it is to find someone to care for her pets while she'll be away on a trip, Carlos and Clarita know they have found the perfect solution. Not only do they have a large unused storage shed on their property where they can house animals, they also have a spacious fenced backyard where the pets can play. Carlos and Clarita are making a list of some of the issues they need to consider as part of their business plan to care for cats and dogs while their owners are on vacation. Space. Cat pens will require 6 square feet of space, while dog runs require 24 square feet. Carlos and Clarita have up to 360 square feet available in their storage shed for the pets and the runs. Their startup cost: Carlos and Clarita plan to invest all of the $1,280 they earned from their last business venture to purchase the cat pens and dog runs. It'll cost $32 for each cat pen and $64 for each dog run. So going back and reviewing what we've done before, we want to create an equation for the amount of space needed for the cats and the dogs based on the available space that we have in the shed. If we remember, it is 6 square feet per cat run, so we call that X. And then if we scroll back up, we can see that it is 24 square feet for each dog run. So I'm going to add that to 24y, and I have 360 square feet available. Now the only thing you're missing here is you must identify what x and y equal. So x is going to be my cat pens, while y represents the dog runs. You can use any variable that you would like here. It's just easier to use x and y, especially when we get ready to graph here in a moment. So if we're going to create another equation, this time is going to be for the cost of these items. So the cat pens will be $32 each, while the dog runs cost $64 each. And I have $1,280 total to spend. And again, you want to identify what your variables represent. In this problem, it's okay that you don't write it again because it's the exact same representation as you had in your first equation. But always get in the habit of identifying these two things. If we go to the next part of the example, they want us to solve each equation for C. And that was, we'll use that as our Y variable. That's our cost, or the number of space we have. Then graph each of the equations on the grid below. So first thing you must know is in order to graph, you have to have all of your equations in slope-intercept form. So it must look like y equals mx plus b. You've got to have a y-intercept and you've got to have a slope. If you don't have your equation set up this way, you've got to manipulate it in order to get it this way so you can graph still. So if we start with the space that we had, we have 6x plus 24y. That's going to equal 360. Well, again, I'm trying to solve for y. I want it to be in y equals mx plus b. So the first thing I'm going to do is subtract 6x from each side. I have to be careful. It's not 360 minus 6 to give me 354. Remember, 360 does not have an x. So I'll be left with 24y equals, and I'm going to put the 6x first, even though it's negative, just so I can keep it in slope-intercept form. So negative 6x plus 360. Now I'm still solving for my variable of y because I'm going to be able to graph it. So at this point, I'm going to divide everything by 24. And at this point, I would suggest that you do not change this into a decimal. Leave this as a fraction. So 6 will go into 6 one time, 6 will go into 24 4 times. And the reason being that we're going to graph this, so I'd rather my slope be negative 1/4 instead of negative 0.25. Because because my rise over run becomes much easier to go down 1 and to the right 4. And then when I divide 360 by 24, I get 15. So all we did in this situation was we changed our original equation, 6x plus 24 equals 360, into y equals. So we solved it as a literal equation here and got it down to y equals negative 1/4 x plus 15. Well, now we need to do the exact same thing for our cost equation. And if you remember, we had 32x plus 64y. That's going to equal 1,280. Still solving for y, so I will subtract 32 from each side. Remember, it's 32x, not just 32. So we're left with 64y equals, and put the negative 32 first, negative 32x plus 1280. Divide everything by 64. And again, I'm going to choose to leave this as a fraction so that when I have my slope-intercept form, it's easier to see my rise over run. So I'll be left with y equals negative 1/2 x plus 20. You can just put this into your calculator, the 1280 divided by 64. Now, the next thing we're going to do here is make sure that we label our graph the way that we want to. I'm going to choose to go up here by, I'm going to choose to go up by 2's for my y side and then 1's by my x's. So this will be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then for my x values, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now remember, if I give you a quiz or a test and I ask you to graph, 4 points of that question is going to come from, can you label your scales? So your x and y, can you tell me how many you went up by? And then also, can you tell me what your x values represent and what your y values represent? So for this first one, we look back up, my x values represent cat pins. So I will put that here, that these are cat pins. And if we look back up, the y value represented dog pins. So I'm going to label that as well. That's where I'll get my total 4 points when I am graphing. I haven't graphed any lines yet. However, I do now know what my x and my y values represent. So I'm going to start with my space function. So negative 1/4 x plus 15. 15 will be right here. And then my slope is negative 1/4, so I'll go down 1 and to the right 4. Down 1 to the right 4. And then I will run out of room. So I'll just connect these points. And then I'll come back and graph as well my cost function, which was negative 1/2 x plus 20. 20's here. Then I'll go down 1 to the right 2. 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 1 and to the right 2. And if you see here, these lines do not cross, then that is okay. So this is the first step in how to graph equations to solve. So as we move on to solve a system of equations using the graphing method, we simply graph both equations on the same coordinate plane, and the solution is the point where the two lines intersect, written as an ordered pair. If we remember, the word intersection means where they cross, where these two lines cross each other, and then we give that ordered pair x, y. So I'm very happy with my first equation. It's already written in y equals mx plus b form. So I will graph first my y-intercept of positive 2, and then my slope is negative 1. So down 1 to the right 1. Or I can go up 1, go back to my y-intercept and go up 1 and to the left. each time. I do want to connect these points. And then I'm just going to graph another line as well, which would be the negative 6x minus 3. So my y-intercept is negative 3. My slope of negative 6, let's go up 6, 1, 2, 3, 4, 5, 6, and then to the left 1. And I can already see where my intersection point here will be, because those points overlap. So what I'm looking for is this point right here. That's our intersection. And that point is negative 1, 3. As we look at the second equation that is given, or the second example, very happy both are already in y equals mx plus b form. So I'll graph this first equation. Slope intercept negative 1. Intercept form is negative 1. And then my slope is negative 1/3. So I'm going to go down 1 and to the right 3. Or I can come back up and go up 1 and to the right 3. Create my line this way. Then as I come to graph the second equation, y equals 2/3 x minus 4. My y-intercept is negative 4. And I'm going to go up 2 to the right 3. And as we can see, that'll be an easy point of intersection. Those points are directly on top of each other. So this value of 3, negative 2 would be my intersection point. When we're graphing, we have two special cases that we must look at. And those two special cases are parallel lines and coinciding lines. So if we think about the definition of a parallel line, those are two lines that will never cross each other. So we think about railroad tracks, opposite sides of a railroad track, they will never cross. If they do, our train will flip over. So parallel lines are when the lines have the same slope, and this is important here, same slope but different y-intercepts. And because these will never touch, the system will have no solution. So if you're looking at a graph and you see two parallel lines, you know they'll never cross each other. The automatic answer is no solution. Now the other special case in this situation is coinciding lines. So this is when the lines have the same slope and the same y-intercept, which is telling me that when I simplify, when I solve for y equals, these two lines are going to end up being the exact same line. Therefore, this system will have an infinite number of solutions. So any point on the line will be an answer if I have coinciding lines. So let's look here at the two examples that are provided. So on number 3, we have y equals x minus 3 and y equals x plus 4. If I start with the x minus 3, that means my y-intercept is negative 3, and I'm going to increase at a rate of 1 over 1. Connect my dots, make a continuous line. And then as I graph y equals x plus 4, I start at 4, and my slope is 1. If you notice here that same slope, so the m equals 1 on both lines, my y-intercept is negative 3 and 4. Same slope, different y-intercepts. The answer to this will be no solution. Okay, and this is because they are parallel lines. So same slope, different y-intercepts. Now as I get ready to graph the examples in number 4, y equals 3x minus 2, start at negative 2. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. I could also go down 3 over 1. As I get ready to graph the second line, though, I notice that it's not in y equals mx plus b form, so I must get it that way. I'm trying to solve for y. So I'm going to start by adding 6x to each side. When I do that, I get 2y equals 6x minus 4. And I choose to put the 6x first just because I want it in slope-intercept form. Then I'm going to divide everything by 2, and I'm left with y equals 3x minus 2. And as I get ready to graph this, I can notice that I do have the same slope, so the slope of 3 to my first line, and the same y-intercept of 2. So as I graph all of my points, and I graph the line, I can see that those two are the exact same. So my answer here would be infinite solutions. And that is because they are coinciding lines. Those lines are the exact same. So we're going to transition at this point back into substitution. Also, we're going to go back and look at Carlos and Clarita. They need to clean the storage shed where they plan to board pets. They've decided to hire a company to clean the windows. After collecting the following information, they've come to you for help deciding which window cleaning company they should hire. So Sunshine Express Window Cleaners charges $50 for each service call, plus $10 per window, while Painless Window Cleaners charges $25 per service call, plus $15 per window. We're going to create an equation that represents the cost for cleaning in terms of W amount of windows. So for the first one, Sunshine, we pay $50 for them to come out, and then it's going to cost me $10 per window. That's going to be my cost that it takes to clean the windows. For Painless, they only charge $25 for coming out, but they charge $15 per window as my cost. So this time, instead of making a graph, we want to solve this algebraically using the substitution method, which is what we practiced with yesterday. To use the substitution method, in this example, we just need to set these equations equal to each other and solve for the remaining variable. So notice we have C equals C, and it is true that C does equal C. So all I have to do is take the first equation, which was 50 plus 10W. We're going to set it equal to, make this actually a W. We're going to set that equal to the other C, which is 25 plus 15W. So at this point, all that I'm going to ask us to do is to solve this. Again, you have lots of options on what you want to do first. I'm going to start with subtracting 25 from each side. So 25 plus 10W will equal 15W. Then we want to get the W's on the same side, so I'm going to subtract 10W. Where I'm left with 25 equals 5W. At this point, it becomes very simple to see how many windows it will take to clean for the price to be the same. That is 5 windows. And if I want to know what that price would be, I would simply plug it in. So I'm going to plug it in to the left side, 50 plus 10 times 5. So that gives me 50 plus 50, which is 100. And if I know this is correct, it'll be true for the other side as well. So 25 plus 15 times 5, which will give me 25 plus 75, because 15 times 5 is 75. And I do get 100 equals 100. We can find that to be true. So the cost of cleaning 5 windows will be $100. Now we typically have 3 different types of ways to solve with substitution. Case 1, both equations are set equal to the same value. So in this case, we just set the equations equal to each other, and then we solve for the remaining variable. So in this case, I've got y equals negative 5x minus 9, y equals 2x minus 2. So we know that y will equal y. negative 5x minus 9 will equal 2x minus 2. I'm going to start by adding 9 to each side. So I get negative 5x equals 2x plus 7. Subtract 2x from each side. So I have negative 7x equals 7. Divide each side by negative 7. And I get my x value to be negative 1. In order to find the y value, you get to pick. You have some autonomy here. So which equation would you prefer to plug into? I'm just going to go back and plug into this first equation. So y will equal negative 5 times negative 1 minus 9. So 5 minus 9 will give me negative 4. So when I write my answer as a coordinate pair, remember we still have to do that, it'll be negative 1, negative 4. For number 6, we see that we have the same situation. So y equals y. So I'm going to set them equal to each other. 3x minus 8 will equal 7x minus 12. I'm going to subtract 3x from each side. So we get negative 8 equals 4x minus 12. Add 12 to each side. And I'll have 4 equals 4x. Divide each side by 4. X equals 1. Then you can pick which equation you want to plug into here to get the correct answer. I'm just going to go with the first one. You can pick either one. So y equals 3 times 1 minus 8. So 3 minus 8. Y will equal negative 5. Final answer on this one would be 1, negative 5. In the second case, we know from one equation that the expression of one variable, in this case, we set that expression, plug this expression into the other. And then we're just going to solve for our remaining variables. So we see that y equals 5x minus 11. So in the second equation, anywhere I see y, I'm going to put 5x minus 11. So I'll start with negative 4x plus 8. Use open parentheses. 5x minus 11. That's going to equal negative 16. Then I just want to distribute my 8. So I get negative 4x plus 40x minus 88 is going to equal negative 16. And I combine my like terms, so I have 36x minus 88 equals negative 16. Add 88 to each side. I get 36x equals 72. We divide each side by 36. X equals 2. At this point, you can plug in x equals 2 into any equation, but I'd rather work smarter, not harder. So I'm going to plug it into the top equation and get y equals 5x minus 11. So y equals 5 times 2 minus 11. I get 10 minus 11. So my y value here would be negative 1. My coordinate pair solution would be 2, negative 1. Number 8, I see that y equals 6x minus 8. So I'll take negative x minus 3, take the y out, and I'll put in 6x minus 8. And that's going to equal 5. Again, I want to distribute. So we get negative x minus 18x plus 24. That's going to equal 5. Combine my terms. Negative 19x plus 24 equals 5. Subtract 24 from each side. We get negative 19x equals negative 19. We divide each side by negative 19. And x equals 1. Then we'll go back and plug it in. Again, you have the choice to plug it into any equation that you want here. But I'm going to choose to plug it into the top one because it'll make life a little bit easier. So y will equal 6x minus 8. and then y equals 6 times 1 minus 8, so y equals negative 2. So I write it as my coordinate pair, 1, negative 2. Finally, in our last scenario, we don't know an expression for one variable from either equation, so in this case, we solve one of them from one variable, and then we're going to take that and substitute it into the remaining. So I want to make a good choice here. I could use a second equation, but if I look, 3 will not go into 17 equally, or 4 equally, nor will 4 go into 17 equally. So I'm going to manipulate my first equation, and I'm actually going to solve this for the y value, because if I notice, 4 will go into all the other values there evenly. So I'm going to solve for y, which means I'm going to subtract 8x from each side. I get 4y equals negative 8x minus 8. Divide by 4. I have a new equation of y equals negative 2x minus 2. So I'm going to use this equation now to plug into the second one. So I will have 3x plus 4 times negative 2x minus 2. That's going to equal 17. I want to distribute the 4, so I have 3x minus 8x minus 8. That's going to equal 17. Combine like terms, so negative 5x minus 8 equals 17. I'll add 8 to each side. When I do that, I get negative 5x equals 25. Divide each side by 5, so x will equal negative 5. So I have options. I can go back to the original equations, either one of those two, or I can come down to my new equation that I formed, and that is going to be the easiest part there. So I am going to plug in this negative 5 into my equation. So y will equal negative 2 times negative 5 minus 2. So 10 minus 2. Y will equal 8. So my coordinate pair for the solution here will be negative 5, 8. Finally, I do the same thing. I'm going to choose to solve for my top equation. So we get negative 3x minus y equals negative 2. Add 3x to each side. We get negative y equal to 3x minus 2. Divide everything by negative 1. And my new equation is y equals negative 3x plus 2. So I'm going to plug this in. 6x plus 4 times negative 3x plus 2. That's going to equal 14. At this step, I want to distribute. So 6x minus 12x plus 8 is going to equal 14. So I have negative 6x plus 8 equals 14. Subtract 8 from each side. Negative 6x equals 6. So when I divide each side by negative 6, x will equal negative 1. Again, I can go back and plug into any of the equations, but I'm going to do the one I created. So y equals negative 3 times negative 1 plus 2. So 3 plus 2, which means y will equal 5. So my coordinate pair solution here will be negative 1, 5.